talk about the weight of these plastics. So what we have is an interest in getting to kind of an average number. Now what we'll do is we'll take this size, which is the most typically used size for water bottles, about the 25 ounces, and I have a very sophisticated digital scale here. And I'd like a volunteer to help me put the power on. Yes, Miss 8 ounces. You come, step right up. Why don't you hit the on button. Now, it's going to zero out the scale. Oh, you're not done yet. And then you're going to put this on, and you're going to tell us what it says.
It says 7/8 of an ounce.
7/8 of an ounce. So what percentage, here's some quick math. I know it's early in the morning, but if we know there's 16 ounces of weight, remember now we're going from 128 fluid ounces of liquid to 16 ounces in a pound of weight. If it's 7/8, we know it's just a little bit less than 1 ounce, right? So what you're going to do is if we know that there are 16 ounces, we would take 7/8 and divide 7 by 8. Okay? And we're going to get a decimal. Ready? I'll do it right here on the phone, because this is really important when we do math to be able to understand the logic of it. So we take our little calculator, or you can do it with paper, but you do 7 and you divide it by 8. And what you end up with is 0.87. So that's about 87% of a single gram. Now we're going to multiply that by the number of total grams, which is 16. We multiply that by 16, and what we end up with is, I did this wrong, hold on. Give me 1 second here. I should have brought the big calculator, but the idea is to literally go at 16 ounces and you multiply it times 0.87. 16 times 0.87. And you end up with a fraction that's about, well, it's about half of a 0.05 of a pound. So, right, if it was just 10% of a pound, it would have been 1.6 grams, right? If we start with 16, 10% of that would have been 1.6. Half of that is about 0.8. So what we're saying is that this adds up to like that 5% of a pound. And what we're going to do today is we're going to take all your bottles and we're going to multiply them by 5% of a pound to see what the total weight is of all the plastic that was used by your whole class in the group here. So part of the check sheet, which is over in my little resource here, is to literally now take the totals and multiply it by, in this case, 5% of a pound. So we're going to end up with the totals. Before we do that, though, we're going to go through the other categories. So let's talk about some other ways to save water. One is surprisingly related to paper towels. Who can tell me why saving water has anything to do with paper towels?
Paper towels come from paper and paper comes from trees and trees use water.
Pretty close. Right, we know that the trees whisk up with their roots all the water, and through the capillary action they're feeding the leaves and they use water. So certainly if we reduce the amount of trees that we cut down, we can retain more of the water in the aquifers. Yes, that's the real meaty answer, which is the process of making the paper towels from the raw material uses a lot more water than actually taking the old paper and recycling it into paper towels made from recycled fiber. So you can recycle paper more than once.